Okay. Complete the function body below according to the docstring description. Zigzag zip. Return a string made up of alternating letters from S1 and S2, starting with S1. Okay, that should be easy. So you're taking two strings, and you just want to zip them together. So let's do that. Oh, that was last Monday, wasn't it? I was going to call everything foo. It took what? Two strings? And should return a string. And what else do we know about this? Okay, I should probably follow their convention. Okay, so how do we do this? We just want to alternate between the two. So I guess this one would be best with a counter. So for k in range, length of S1. And I suppose, did they say that these things were equal? Yep, precondition, they're equal. So that should be easy. Okay, so we have an answer. It's empty. And then I just want to say answer plus equal S1 at k plus S2 of k. It's not much. I think this should do it. Return answer. Excuse me? Isn't that what I did? One of them's, okay, did I read this wrong? Return a string made up of alternating letters from S1 and S2, starting with S1 at 0, then S2 at 1. Oh, I see. So I don't take both of them. Okay, I see. If k mod, remainder 2 is 0, then I want to append, is it S1? Yeah. And then else answer append this. Yeah? So like, that's really why we have this modulo operator. It's so you can do like different things. Well, there's many reasons that we have it, but this is one of the main ones, right? So that you can do a different thing modulo a remainder. Like for example, on your assignment that you're doing right now, it wouldn't be a bad idea to keep the count of the line you're on mod 5 or mod 7, right? Depending what dictionary you're in. I'll give a hint, right? There's like several ways of doing the assignment. Like the other way of doing it is with a while loop, and then you can just read manually, right? I can put 5 read lines. I can read in 5-line chunks in a while loop, or I can read 1 line at a time in a for loop and keep track k mod 5 or something like that. So those are 2 ways. In the solution I leaked, I did the 5 read blocks, right? Maybe I shouldn't explain how my solution works before you guys write your solution. As a reminder, please don't include any of my solution in your solution, right? Because you're going to have to try and explain to me how my solution ended up in your solution. That's not going to be a pleasant conversation. Because I'll say, you're a liar! You're lying! Okay, so what do I have? Foo, and A, B, C, 1, 2, 3 should be what? A, 2, 3? A, 2, C. And then the reverse of this should be the other thing. 1B, 3. Okay. So that's just 4 marks. Where's the last mark? 1 mark. The docstring for zigzag zip includes a precondition. Briefly explain the error that could occur and cause the code to crash if zigzag zip was called with arguments that do not meet the precondition. Okay, so suppose we pass in 2 strings that are a different length. What error would we expect to throw? Yeah, probably invalid index, right? We're going to ask we're going to try to access one of the lists beyond its last index. Well, let's just try, right? So if I take this out, string index in S2, and the opposite should be true if I take this out. We should get a string index error in S1. Really? Oh, because I've moved to the length of S1. Okay, I see. Well, it only did the one, right? So it would only error if the second thing is the longest. But that's due specifically to our implementation. Okay. 2. Fill in the boxes to complete the type contract and docstring examples. Okay, so I guess this is something that we have to read, understand how it works. So what is this doing? So it takes in v1. Okay, so it takes in a list of strings and an integer. Wait, doesn't that mean this is already wrong? I don't get it. Okay, so am I missing something, or should this integer indeed not be there? It's not included anywhere else in... Okay, so we're just going to assume that this is a typo, right? Because clearly this is not taking an integer. Okay, so feel free to call us over if this ever happens on your exam, right? I just invigilated a math exam on Friday where there was a major mistake in it. Okay, so forget about this. What are we returning? Nothing, right? That's really easy to determine because there's no return statement in this, right? You see how there's no return? So it can't return anything, right? So if this is going to return none. I wonder how broken this question is. So what is it doing? Okay, so we're running an index, throughout the whole length of the list, provided that the word length, so the words have to be increasing in length for us to go to the next iteration of the while loop, right? This is just a restriction on the counter itself. That's saying don't run off the end of the list. That's something normal. But this says that the length of the word at I should be bigger than the length of the word at I plus 1. Right, so we're only moving provided that the next word is longer than the current word. Okay, so then temp gets word I. Temp gets words at I. And words at I gets the next words at I. Okay, so we seem to be swapping something. So while the length of a word is bigger than the word that comes after it, we should swap. This is sort of like bubble sorting on the length of the word once. So none of this question makes any sense. Oh, no. They're working in place in V2. I see. No, I see. Because they're printing it afterwards. Well, we're in a good position, right? Because we can just type it into the compiler and check our answer, which you won't have on your exam. So let's try. So I think this condition basically increments I provided that the word at I is bigger than the next word. So if this one came in, this panda is bigger than both cat and ox. So I think if we put v1 through this function, we should get back cat, ox, panda, beluga, dogs. Right? It's I don't actually recommend for these questions you do the trace line by line. For these questions, you should sort of look at the code and understand generally what it's trying to do and then answer the question. If you can. You can always revert to just trace it. Yes?
What if they intended to not include return statements so that the word will return the same as the original?
But the pointer is called words, right? So we're actually doing an in-place change on V1 and V2. So that's what they're doing. They're asking us to make in-place changes on the list. Yeah. It's exactly like the rotate map function. Remember, it makes sense to not pass around a list, right? Because if this list was huge, which is often the case when we're computing something, right? We don't use computers to compute stuff that we can compute. It would be really inefficient to duplicate that list every time it needed to be passed to something. So the default behavior is more sensibly, this is where you can find the information. Okay, so let me just type this into the compiler. Can I copy this? I really doubt it. Oh, well, okay. I think And this, where are the semicolons? Nope, I don't think that's anything. I'll just type it in. Boom. Go away. So we have function which takes words. So I guess this should just return none, right? That gets you 1 mark. I is 0, while I is less than the length of words, minus 1. And length of words at I is greater than the length of words at I plus 1. Temp is equal to words at I. Words at I is equal to words at I plus 1. Words of I plus 1. You know, if I was a good instructor, I would have done all this yesterday. Not wasted your time. Okay, so we've read that in. How do I get you back? Come back. And then all this has to be tabbed out. Oh, no, it is. Let's read it in. So what did I say? Okay, so I predicted on this that we would just move Panda a couple X's, or words. Okay, so my prediction for words, so I basically said we're doing bubble sort on the length of the word. So if that's true, Panda should bubble up to Beluga. So let's see if that's indeed the case. What did I call this? Foo? Oh, right, words. Yes! So my basically bubble sort is basically correct. Okay, so that means we're not done yet. Okay, so I managed to predict the output. I like questions like this, where we just sort of flip the script on you guys. Now predict the input that gives you the output, which forces you to understand what the algorithm does. Do you understand that? If we give you input, you can trace. If we say, give me the input that gives this output, then you have to understand. Right, so I like this. Okay, so what do I have to well, you can just give it the list itself. Then nothing will happen. Right? Pi is not bigger than cake, so you're, will that work? No, it's an AND condition, right? So the loop's going to exit. If I give it that, if I just give it this itself, nothing's going to happen, right? Because that's the output, right? So if I give the input, it's just going to return the, is that true? No, because that's yeah, obviously that's dumb. Because after two steps of bubble, you're going to have like stuff stacked at the end. But I think if I give it this, pi is not bigger than cake, so the loop is going to terminate immediately. Right? It's not even going to step into the loop once. Right? So all we have to do is give it this. Let's see. Cool. So we already got what? Okay, so that was, we got this one, we got that one, and we already got the one before, right? So we already have 5 marks. How much is this out of? 75. Okay, so we already have 5 and 7 maybe. Anyways, what I'm trying to say is we're doing good. Briefly explain what error would happen if we change the loop condition in function from, okay, we could step off the end of the list, right? So we could get a index out of bounds error. Write a formula in terms of k, where k is the length of words that describes the maximum number of comparisons made on a call to function. Okay, so we're doing comparisons here. So how many comparisons do we do? Okay, so the worst case comparison is that the thing at the front of the list is bigger than everything, in which case it will bubble to the very back, in which case we do n minus 1 many comparisons. And a list of length 3, you have to bubble twice to get to the top, right? So it's n minus 1. But there are 2 comparisons here, so we're going to get 2n minus 1, like 2 bracket n minus 1 close bracket, which is order of n. So I guess here, so okay, so sorry, they used k for the length of the word. So we're going to have, it's order k, it's linear in k, or exactly 2k minus 2. See, like, blanks there, so you got to ask me questions so I can help guide you, right? Okay, there's at least one person in here who didn't understand what I just said. So who's going to be honest enough to admit it? Thank you, right? So they're asking us how many comparisons we're going to do, right, in this algorithm. Right now, they're asking us the worst case scenario. So just assume that whatever case you're using is going to require the maximum amount of comparisons. The comparisons, the only comparisons in this algorithm are here, in this function. Like, it is literally the only place where you can find comparisons. The comparisons less than, right? That's what they're asking about, the less than comparisons. So they're saying, if I give you a list, how many times will this have to trigger? How many lines can this, what is the worst case number of times this while loop can trigger? All right, so if the list is of length k, the worst that you can ever do is have to walk the whole list, right? -1, but who cares about those constants, right? So if I walk a list of length k, I'm going to do k minus 1 many comparisons in the worst case, and there's 2 comparisons on this line, so I'm going to do 2 k minus 1 operations in the worst case. Better? Yeah? Okay. So the answer to this was O of k. It's linear, right? Because we only care about the degree of the polynomial and not the other stuff. Write a formula in terms of k, where k is the length of words that describes the minimum number of comparisons. Easy, 1, right? Because we did one, right? We had an example where it did 1 comparison. So the minimum number of comparisons this can do, hold on, wait. This is kind of tricky. Well, it is still 1 because AND is a short circuit, right? So if we do this comparison and it fails, then it won't bother doing that comparison. So we can properly do exactly one comparison in the minimum case. Although you're going to answer constant, right? So even if you answered 2, it doesn't matter. The point is we're going to do a constant number of comparisons in the minimum case. Right? We can do 1, maybe 2. Which of the following best describes the worst case running time of this function? Constant, linear, quadratic, or something else? Huh? Linear. Great. Complete the body of this function according to its docstring description. Ooh, return a dictionary, where the keys are the individual words in text and the values are the positions in the text where the words occur. Starting at 1. What? Why would they do that? That just like needlessly complicates everything. It's like, you know that thing where we've been yelling at you to zero index all semester? Forget about it. For this question exactly, forget about it. I'm going to angrily drink from my coffee to calm down. Include punctuation in numbers and words. Okay. And convert alphabetic characters to lowercase. Okay. So this convert alphabetic characters to lowercase. Oh. Okay. So I hope you guys are fairly familiar with the string built-ins at this point, right? Because we've been doing a lot of stuff with strings over the semester. So you're going to need the, so surely there is a string built in that like makes something a lowercase. What is it? Dot lower? Okay. And remember, you can always you can always flip to the end of the exam, right, to look for the built-ins. What else do we need? We need to find something. So we found, I always forget which class you guys are. Well, the smart class, but I forget what I've discussed with you guys. But so I think we discovered that we could find a string in a string. That the string built-in find isn't limited to characters, right? So I think we're both going to need lower and we're going to need find to solve this problem. This will be good because I can show you some stuff on dictionaries. Maybe it'll help you with your homework. You guys are aware you're building tuples, right? Okay. We had to do that because dictionaries can't key lists. Right? Do you think it's sensible that a dictionary can't key a list? That'd be a good exam question, right? Why should we disallow dictionaries to be keyed by lists? Yeah. Wouldn't it be weird for a key to change, like, in the dictionary without telling you? Right? Like, I could key the list 1 and then append something to that list. So the real question becomes, Well, what have we keyed? The values or the memory location? And keying by memory location wouldn't be very useful. And keying by lists that can change isn't very useful. So that's not an exam question, although now that I told you the answer, it would have been better if it was. But in any case, it'd be really weird for your keys to change underneath. Words in text. Okay, so cats, 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 cats. So the word cats start at 1. Wait, why is there a 2? Oh, because it's the second word. I see. So it wants us to number the... Okay, so it wants us to break up the sentence into words and then give the position according to those words. I don't like this question. So do I... Oh, okay, never mind. Okay, so we do include punctuation in such a way that cats is different than cats followed by punctuation. Yeah. Yeah, something like that. Yeah. I think this shouldn't be too hard, actually. Okay. Shh. Yeah, but I'm not going to use find on the list because we have to process every list member anyways. So let's just walk the list and keep an index and then feed it to the dictionary. This will be quite easy, actually. Okay, so def, foo, I have to take in a sentence, right? Text, okay, text, which is a list of strings. Okay, but they don't do that in here. I'll do it. From typing, import, list. Huh? Oh, okay. Okay, so I'm just going to do the thing that we're supposed to do. Okay, so I'm going to take text and I'm going to split it on spaces. Okay, so this should, wait, does this return or does it, this returns? Okay, so I'm just going to overwrite text. So now text, words. Okay, so now I have a list of words. Okay, so now I need to, I really want to do a list comprehension. Can I do one list comprehension? Okay. Yep. Yeah. Well, if it's on your exam, I'm pretty sure that you didn't cheat. Yeah. You can use a list comprehension. It's just that I would have had to write a for loop here, and this is so easy, right? Just to say, because I see this list as like a set, and then I can do a set comprehension through it. That just go through it and just lower everything in the words. So let's just give this a try. So I can say something like foo. I can scream everything at you guys. Hello world. Oh wait, that's not what I do. Just a string. How my mom writes emails to me. Okay, it works. See, everything was separated. And this is the reason I do this is because it's kind of like a fake map. And I'm a functional programmer. You'll learn what map is soon. Okay, so we have words, which are all in the lowercase. And now I just have to say for word in words, and I need a dictionary, right? So here's my answer. Hash. For word in words, no, I should do something better than that. For K, words in enumerate words, right? Because this allows me to go through the words with a counter. Then H at word should be appended K. Okay, which means that I first have to check if the word is in H. And if it is in H, then I can do that. Else I have to create it. Something like this. All right, because they're dicks, right? Okay, then I return H. Okay, so you guys should have this in a bunch of places in your assignment code, right? You can't just create something, you can't just append to a list, right? You always have to check if the key exists first, then update it. Or use a default dictionary, which you don't have access to. Or you can use the default, there's a trick where you can sort of set the default value and append at the same time, but don't. It's confusing, do this. So I think this should work. Okay, but that's not a very good test case. How my mom, email. Which email?
The chapter at 6.
At 6. Why is it in my dictionary? Oh, this. Oh. What did they say we're supposed to do with spaces? Yeah, it's a exam and this is worth 5. I doubt we're gonna have to go that intricate into the cases. Yeah, you could always go in the dictionary and pull it out. Like you could always write something at the end of this, like h at space, delete it. But anyways, good enough. Certainly this will be good enough for an exam. And that actually wasn't that complicated of a piece of code, right? So, although you may have to have written this as a list, although, like here you can just say something like word is equal to word.lower if you hadn't done it up there, right? Okay, so that's fine. 8 marks we just got for that. For the next 2 parts, consider the following function that operates on the return value of get positions. Was there questions about that code? Okay. Write a formula in terms. Oh, they want us to calculate the. Wait, how does part A relate to part B and C here? It doesn't. Okay. For the next 2 parts, consider the following function that operates on the return value. Oh no, it is related. They're saying you're getting output from the procedure you just wrote, and you're going to give it to this new thing. Okay, so it's going to take the dictionary that we just created and return a bool. So what's it going to do? Has single word D. Okay. So if you read through this, what is this doing? It's taking in a word D, it's checking if that key is in the dictionary, and then it's checking that the length of the value at that key is 1, which means the interpretation is that the word appeared in the text exactly once, right? So like, has single word, okay, it's an okay name, it's not the best name, right? So write a formula in terms of k to express the minimum number of comparisons when the has single word function is called. Oh. But you guys don't know how a dictionary finds its key, do you? Okay. So something that you need to know, which is it's not on your exam, but I'm going to tell you, right? You should learn it anyways, despite it not being worth any grades. Access to a dictionary is constant in all cases, right? It has this magic way of finding entries. That's why we use hash tables. They're magic in some sense, right? So you could assume whenever you're looking for something in a hash table that you get it back in constant time access, which is incredible if you think about it. So the answer to part B is 1, right? The minimum number of comparisons you do is 1, or not 1, but it's linear, right? You're doing a constant number of comparisons. So the minimum number of comparisons when the has single word function is called is 1. Right? Write a formula in terms of k, where k is the length of D, to express the maximum number of comparisons made. Well, it's hard for me to answer these questions. We didn't really tell you how dictionaries work. But in the worst case, access to a dictionary is equivalent to access to a list. Right? In the very worst case, the dictionary is as inefficient as a list. So the answer to part C should be K. Right? You have to walk the entire dictionary to find the key. Right? It's like the last thing that you've searched for. You'll learn more about this in data structures. Like now you may sort of be getting a feeling for what you're going to be taught in data structures. Right? We're going to have to teach you how all of these magic data structures actually work. And then you're going to have to code them so that they work and become less magical. Yeah?
Why isn't the minimum number of comparisons 0?
Because how do you, like, we're at least asking if the key is in the dictionary.
The for loop past that?
No, the for loop isn't, where's my thing? See this in? There's an implicit for loop there, hidden. Right, when I say, if I give you a list of numbers, like 1, 2, 3, and I say, is 4 in that list? That has to do 3 comparisons. So did everyone hear that? This in is linear, right? How can you tell if a member is in a list? You have to walk the whole list, right? So don't just be searching for loops when doing these complexity. You have to think about the individual operations that you're acting on. And in is definitely worst case linear, right? Even though it returns a bool. But you should, like, even if you didn't believe me about it being linear, certainly it takes more than 0 comparisons to find a key in a dictionary.
Even if the dictionary is empty, it just checks it once to see if there is.
But even that is a comparison, right? Even to ask if the dictionary is empty is like an operation. So you can't get 0 anything. The minimum number of operations you can do is constant. And in fact, 0 is a constant number of operations, so it falls into O of 1 category anyways. Right? There's no special category for does nothing, right? 0 is technically a constant number of operations. Okay, what's next? And how much time do we got? Lots. Complete the function body below according to the docstring description. Okay, so I should tell you that your exam is a lot, well, not a lot different than this. That we've asked you to write, you see these like pieces of code where we give you a lot of white space? We've decided we don't trust you with white space. We've wrote in, so a lot of the questions are, we've written most of the code for you. Please fill in the blanks so that the code will execute properly. This is more so the... It's so these guys have an easier time, right? It's partly so these guys have an easier time and so you have an easier time. But we're really forcing your code to look exactly similar so these guys won't screw up. Okay, so modify each value so that each number is rounded down to the nearest integer value. And return the accumulated lost amount. Okay, so this is a function that asks us to take in a list of floats, to truncate all of them. Do you guys know what the term truncate means? No, it's to put on a trunk. Many of you didn't know that. It just means to chop off the fractional part. Right, so 2.3, so truncation is a faster operation than rounding. Because rounding, you have to find the nearest thing and move towards it. Truncation basically says always go down. It's equivalent to floor. Right, so it basically just means chop off the decimal. Okay, so here the decimals that we have are 0.5, 0.3, and 0.1, so 0.81 should be returned. Okay, so we don't actually have to return anything else. Okay, so we just have to walk through the list, and we need some way of obtaining the fractional part of the decimal. So, how would you do this? Right, you need some way to truncate, and I'm not sure that we've given you any way to truncate, so you may need to be clever in how you get the fractional part. Huh? Oh, they told you how to truncate. Well, easy then. Jeez. And they told you how to get the integer part. Because I wouldn't have told you this part. I would have told you one and not the other. Right? Because getting the integer part gets you the fractional part, and getting the fractional part gets you the integer part. So they gave you too much here. They're really babying you here. I didn't know that. This is interesting. Because like remainders shouldn't work on... Actually, no, I no longer like this. Well, what does it mean to integer divide a float? Right? Any float is evenly divisible by a float. Right? We don't have a notion of divisibility for the reals. Right? Like 2 divides 4 because 2 times 2 is 4. What does it mean for 3.3 to divide 9.9? Like anyways, we don't have a notion of divisibility on the reals, so why should we have a notion of integer division. Anyways, I started liking it, but now I don't like it. All right. So what was I taking? A list of floats? Okay, I'm gonna bring in typing. From typing, import list. This is a list of floats, and this is gonna return a float. Whoops. So this should be easy, right? I need to accumulate something. So I'm gonna say 4x in x's. What do they ask me to do? Accumulate the fractional part? Easy. Answer plus equal, yet one moment, this, return answer. Okay, what's up? Where? It just creates, so this is basically letting us go through the list, and it's gonna count for us. So I could have done this instead. Okay, so if I take this out, I could have said something like, for word in words, k plus equal 1. And then I had to then I would have to make a k. I'll show you exactly what it does. Given a list of something, enumerate creates a iterator over this, which is why I have to list it to show you what it contains. Whoops. Creates a list of tuples, where the first thing is the counter, and the second thing, okay, hold on. X is A, B, C. It's just a dirty trick to get a counter when you're enumerating through something, right? And that's what the word enumerate means. It means to count through a set and to give each member of the set a individual label, which is an integer. Okay. Okay, so this foo should work. Foo of, what did they say, 1. It was something like 5.5, 5.8, and 1.01. I don't want to add. 7.71? Someone confirm? 0.71? Exactly what I wanted. Oh, why did I do that? That's not what I want. Hooray, float arithmetic. Yeah. Yeah, close enough, right? But I'm actually curious what's introducing this. Let's check. It's a little bit bizarre. Wait, but how come it's not printing? Hold on. Okay. So I think the other way would have worked better. That I take the x and subtract its integer part. Let's see if that will give us a better answer. No. Okay. Float suck. That's the lesson that we've learned today. Next. So that got us another 6 marks for that. My God. 4 lines of code, right? If only your exam was this easy. You guys don't like sorting? This is like, sort is like the most canonical computer science problem. If you don't like sorting, that means you don't like computer science, right? Computer science is more than just learning how to code a bunch of stuff. That's what the engineers do. You're computer scientists, right? You need to have a higher level understanding, right? That hurts my heart that you guys don't like sorting. But what's the problem? We know in each of these sorts what happens after one iteration, right? So let's just think, without knowing anything right now, okay? we can probably come up with what insertion, selection, and bubble means, right? So selection, why would we choose that? Well, because we select the largest thing, or we select the smallest thing and move it to the front, right? That's what we do in selection. In insertion, what did we do? Okay, screw insertion. Bubble. After one iteration of bubble, there should be the largest element. Okay, so after one iteration of bubble, one element should be sorted at the back. Right? That's what happens after in bubble. And what was selection again? No. Okay, so I know what select does, I know what bubble does. What was the fundamental thing in insertion? I could tell, yeah, I could put a member into a list in its right place. Right? So that one, I think, we were taking from the end of the list and inserting into the front of the list. Okay, so after one iteration, one member of the list should be sorted at the front of insertion. See, that wasn't that bad. You just had to think a few seconds. Okay, so for each list and each algorithm, consider whether it's possible that 2 passes of the algorithm could have been completed on the list. Okay, so I said after 2 passes for insertion, 2 elements have to be sorted at the front in insertion. Although they really should have specified that these were ascending sorts. And so you should also raise your hand and say, what do you mean by sort? Typically, when we say sort, it's implicit that we mean in increasing order, right, or non-decreasing order. Right? Okay, so given that insertion has, after 2 passes, has to have 2 elements sorted at the front, can this one be a list that has been passed over twice? Are the first 2 elements sorted? Yes. So yes. Are the first 2 elements sorted? No. Don't make me say it every time. Yeah. Yes. Okay? Okay? So don't be scared. Not scary. Selection. Same thing. I think it's going to be exactly the same as insertion. Right? Because we're selecting from the... No. It's from the back this time. Because I select from the front and put in the back. So are the last 2 elements sorted here? Yeah. How about this? Okay, but remember, it's not that they're sorted. It's that they're the 2 biggest members of the list already at the back. So how about this one? No. How about this one? How about this one? Yes. Okay, so bubble, 2 passes means the 2 biggest things should be at the back. Yes? So is that okay? Should I pull up your exam and see if there's a question like this? You should be able to do this. So review the actually don't review my lectures because that's like 2 hours. Let's go to Wikipedia. I'm sure you can YouTube something on sorting and someone will give you a good 5-minute explanation. Right? But you basically don't study the algorithm itself, study like the higher level abstraction of it. You just need to be able to just memorize this. What happens after one iteration of insertion, selection, and bubble, right? And the answer to that question is, the front of the list is either populating in sorting or the back of the list is populating with sorting. So, okay, well, maybe we just skip this one. But anyways, we did that one. Fill in the blanks. Oh, so your exam looks more like something like this. Except that they're not boxes. Like we wrote something like and is equal to code 1, and then I think there's like a table that says what is code 1 equal to in order for this to work. Okay. Return a list containing the keys and words sorted in ascending order by the length of their associated lists. Okay. So you can sort given any, remember we're talking about the less than operator over objects, right? So when you sort something, you also have to tell what we're sorting on, right? So you can sort a list of lists if you say, look, just compare the lists by their length. And this program is telling you to do exactly that, to sort a list of lists based on the list's length. So oh, why is there a dictionary? Return a list containing the keys and words sorted in ascending order. Okay, well, I lied, but still everything I said is basically true. Because like now we're being asked to sort strings, and we have to sort those strings based on the length of the string. All right, so just replace everything replace every list I said with the word string. So, okay, so we have L. That is a list of the keys of the dictionary. So you guys know that you can pull out the keys of the dictionary like this. End is equal to what? What's end? Well, end is not equal to 0. Okay, so end is a variable which is going to be the break condition, essentially. Okay, so let's just keep that in mind, that we have a break condition. For I in range end, that's strange. Okay, so they want us to count down with end, I imagine. So you start end at maybe the length of L and you move downward. Am I late? Oh, geez, go, it's 11, yeah. Next time, stop me.